Good morning, friends. I hope everyone is doing well. I request everyone to watch my videos in a sequence for better understanding. If you really like my teaching and my efforts, please press the like button, share the videos with your friends, subscribe to my channel, and also press the bell button to get the regular updates. In the last video, I have discussed about the SR flip-flop, its characteristic table, characteristic equation and excitation table. What is the problem with the SR flip-flop? When S and R inputs are 1, it is giving the invalid output. Am I right or wrong? So that is the problem with the SR flip-flop. To avoid the problem or to overcome the problem in the SR flip-flop, the researchers have designed JK flip-flop. So we will discuss in this video about the JK flip-flop, its characteristic table, its characteristic equation, and also the excitation table. And another important thing is that how it has overcome the problem which is there in the SR flip-flop. All these things I will discuss in detail. So I request everyone to watch the complete video for better understanding. First, let me discuss the JK flip-flop circuit diagram. If you see that I have designed the J and K flip-flop, JK flip-flop using the Nand gates. I hope these 4 gates are looking as a Nand gates. If you see the difference in the SR flip-flop and JK flip-flop, in SR flip-flop, these 2 Nand gates have only 2 inputs. One is S and R, and we have another input is clock. But if you look at the JK flip-flop, these 2 Nand gates having the 3 inputs, which is J, K, clock, and Qn complement and Qn. And these 2 Nand gates are similar. They are looking as a SR latch using the Nand gate. Am I right or wrong? Is it clear? So with this one we will discuss what is the characteristic table of JK flip-flop. And remember one thing, this is Q and this is Qn complement. Both are single only, means it is a single variable. If it is 1, this will 0. If this is 0 and this is 1. So the characteristic table of JK flip-flop will consist of inputs J, K, Qn, which is a present state, and then we will have Qn plus 1, which will be the next state. So totally I have 3 inputs J, K and Qn. The one output is Qn plus 1. If I have 3 binary variables in the input, how many input combinations I can get? 8 combinations I can get. What are they? 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. Similarly, I have another 4 combinations such as 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So totally I got the 8 combinations. Now what we will do is that similarly in the SR flip-flop, what we have discussed, like each case, when J and K value is 0, 0, what will be the next state? The present state can be 0 or 1. Similarly 0, 1, 1, 0, 1, 1, all these things we will discuss in detail. Now what I will do is that J and K value I will keep it as 0, 0 initially. Means I want to discuss this case. Okay, and clock is 1. Now tell me what will be the Qn plus 1 is equal to. Qn plus 1 is equal to, first I need to find the input for this one. How I will get the input for this one? What will be the output of this Nand gate? This is 0, 1, Qn complement. Are you able to understand? Sorry for it. 0, 1 and Qn complement. 0 and 1 and Qn complement. And then you have the whole complement. 0 and something will be 0. So which is 0 complement, which is 1. Okay. So you are getting the input as 1 here. Okay. Now, if you are getting 1 as an input, Qn plus 1 will be equal to 1 and Qn complement, okay, then you have the whole complement because you are doing the Nand gate, okay. Now, let me discuss what will be the output of Qn plus 1. Qn plus 1 will be equal to Qn whole complement is equal to Qn. Similarly, we will see the qn plus 1 complement, okay, is equal to, first I need to find 0 1 qn whole complement will be equal to 1. So 1 and qn whole complement is equal to qn complement. If you see this one, qn plus 1 is giving qn plus complement is giving the qn complement. So the next state is equal to previous state. The same way, see, for these 6 cases, 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1, the JK flip-flop and SR flip-flop works in the same way. Okay, so anyway I will discuss it. Now if you see that qn plus 1 is equal to qn, so which is nothing but whatever the qn is there, qn plus 1 also will get the same thing. There is no change. Are you able to follow with me or not? The same way the SR flip-flop also worked. Now we will see the J and K value as 0 and 1. What will happen? J value is 0, K is 1. Now we will look at it. We will erase this one. Qn plus 1 is equal to, if I want to find the Qn plus 1, I need to find this input. Now this input is 0 and 1 and qn complement. Whenever there is a 0, this NAND gate will produce the 1 as the output. Okay. Now this is 1, 1 and qn, which will be 1 and 1 and qn whole complement, which is equal to qn complement. So this input will be qn complement. Are you able to understand with me or not? Now qn plus 1 is equal to 1 and qn complement whole complement. Why I am keeping the whole complement? Because this is a NAND gate. So which is equal to qn complement whole complement is equal to qn. So we got the qn plus 1 is equal to qn. We will see the qn plus 1 complement is equal to qn and qn complement whole complement. Now what is A and A's complement is equal to 0. If you want, you can verify with the truth table also. Okay, so this will be 0. 0's complement is equal to 1. Now if you look at it, qn plus 1 whole complement is saying 1, qn plus 1 is saying qn. Now what is the meaning? This one complement should be 1's complement is 0. So this will produce 0 as the output. Okay, so this one we will call it as a reset. Are you able to follow with me or not? Now we will see the next one, 1 0. When J value is 1, K value is 0, what will happen? Okay, now qn plus 1, if I want to find, I need to find this output. 1 and qn complement whole complement will be qn. Will you agree with me or not? Now this is 0 and 1 and qn. Whenever there is a 0 in the NAND gate, the output will be 1. Okay, now if you look at it, qn plus 1 is equal to qn and qn complement whole complement, which is equal to 0 complement is equal to 1. Similarly, we will see qn plus 1 complement is what? Now this is 1 and another input is qn whole complement is equal to qn complement. Now if you look at it, qn plus 1 is saying it as 1, qn plus 1 complement is saying qn complement. If it is 1, qn plus 1 complement will be 0. Are you able to understand? So when J and K values are 1 and 0 respectively, whatever the qn previous one, qn plus 1 will always produce the output as 1. Okay, so this one we will call it as a set condition. Are you able to follow with me or not? Now we will see the next case, J and K value when it is 1 and 1. So I request everyone this case to listen properly. Okay. J value is 1, K value is 1. During this, in SR flip-flop, we will get the invalid output. Now we will see how the JK flip-flop overcome this problem. J value is 1 and K value is 1. What will be these outputs? 1, 1 and Qn complement. You check it, 1 and 1 Qn complement whole complement is equal to Qn complement whole complement is equal to Qn. So here you are getting the input as Qn, and similarly 1 and 1 and Qn. In place of Qn complement, if you keep Qn, which will be equal to Qn complement. So here you are getting the input as Qn complement. Are you able to follow with me or not? Because this is 1 and Qn whole complement is equal to Qn complement. Now we will see. Now look at the JK flip-flop Qn plus 1. Next state is equal to Qn and Qn complement whole complement. Now it is looking as A and its A's complement is equal to 0, which is equal to 0's complement is 1. Am I right or wrong? Similarly, if you look at Qn plus 1, complement is equal to Qn and Qn complement is equal to 0's complement is 1. Now you can say that again we are facing the problem Qn plus 1 and Qn plus 1 complement is giving 1 and 1. Now when JK flip-flop, this 1 and 1 will be there for some time. After that we will get the toggle condition. How it is I will discuss. Okay. In the next few clocks, what will happen is that Qn we will give it as an input here. We will consider the Qn plus 1. Okay. That Qn plus 1 we will keep here. Are you able to understand it or not? Let me repeat again. We will give the, after few clocks in JK flip-flop, how it will work. This Qn I will give. That is what the case Qn we will give here. And we will get the Qn complement. That value I will give here. And what is the output we will produce, we will see. Okay. So, first I need to find the Qn plus 1's complement. How I will get? If I give the Qn here, I will get the Qn complement, and another input is Qn, so which is equal to Qn complement and Qn whole complement is equal to 0's complement 1. So this is acting as now 1. Am I right? Qn plus 1 is equal to 1. Now what will be the Qn? You can verify it. What will be the Qn plus 1? Is equal to 1 and Qn whole complement is equal to Qn complement. So now Qn plus 1 is giving the Qn complement is, now if I give again here, this one I will get Qn. Means next time whenever I am giving this Qn complement as an input here, then Qn plus 1 complement will give Qn. Are you able to understand? If you want to verify, you can verify. Qn plus 1, next time it will give Qn complements, Qn it will give. Are you able to understand? So this is giving the Qn complement, this is giving the Qn. Now it is valid because this is giving the complement and it is giving the complement of its complement. So it will give the, if it is 0, it will give 1. If it is 1, it will give 0. So this condition we will call it as a toggle condition, or Qn plus 1 is equal to Qn complement. Are you able to understand it or not? So this is what the JK flip-flop characteristic table. Now we will discuss the characteristic equation of the JK flip-flop. Okay, how to get the characteristic equation of the JK flip-flop? We have to do the K map using the next state. Okay, now if you look at, we have 3 inputs. What will be the number of cells in the K map? we will have 8 cells in the K map. Let me find those 8 cells first. Okay, you have J and K. Here you have Qn, which is equal to 0, 0, 0, 1, 1, 1, 1, 0. And here you will get 0 and 1. Okay, now if you have to find the simplified one, what you will do? You have to find the minterms. How you can find the minterms? Wherever this function is producing the output as 1, they are the minterms. 1, 2, 3, 4 minterms are there. Place them in the appropriate position. J, K is 0, 0 and Qn is 1. Jk is 0, 0, Qn is 1. Here I am keeping it here. And next one is 1, 0, 0. 1, 0, 0. This is the next position. 1, 0, 1. 1, 0, 1 is this one. 1, 1, 0. 1, 1, 0. This is the next one. Now if you have to find it, first I need to find the prime implicants. This is the one prime implicant. This is the next prime implicant. Am I right or wrong? Now we will simplify using this K map. Now how can I do? First I will take the column. What is the column here? 1, 1, 1, 0. So 1 is common, which is J. Okay. And in the row side we have the 0, which is Qn complement. This is one minterm. Let me find another minterm. This is 1, 0. This is 0, 0. So I have the 0 as common, which is K complement. Okay, here I have the 1 is common, which is Qn. So the characteristic equation of the JK flip-flop is Qn plus 1 is equal to J and Qn complement or K complement Qn. So this is the characteristic equation. This is the characteristic table. Now let me find out the excitation table of JK flip-flop. Okay. Now the excitation table will consist of Qn and Qn plus 1 are the inputs and the outputs are J and K. Am I right? If I have two inputs which are binary numbers, how many inputs combinations I will get? 4 combinations. What are they? 0, 0, 0, 1, 1, 0 and 1, 1. These are the 4 cases. Now we will look at what is happening. When Qn and Qn plus 1 should be 0, 0. So this is one case and this is the another case. Are we getting any another case? No, only 2 cases we are getting. J value is 0, K value is 0. Here J value is 0, K value is 1. So J is 0, K is don't care whether it can be 0 or 1. Are you able to follow with me or not? The next 2 cases 0, 1. Meaning is that Qn is 0, Qn plus 1 is 1. This is one case, this is another case. Now if you look at J value is 1, K value is 0. Here J value is 1, K value is 1. So J value is 1, okay, K value is don't care. It can be 0 or 1. So this is completed. Now we will look at the next one. Qn is 1, Qn plus 1 is 0. Okay, this case and this case. Am I right? Now what is the J and K values? J value is 0, K value is 1. Similarly, J value is 1, K value is 1. So always the K value is 1, J value is varying 0 or 1. Am I right? So that's why I am keeping don't care. Now next we will see the final one. Qn is 1 and Qn plus 1 is also 1. This is one combination. This is another one. Look at the what is the J and K value. J value is 0 and K value is 0. J value is 1, K value is 0. So which is don't care and 0. So this is the excitation table of the JK flip-flop. This is the circuit diagram and this is the characteristic table. I hope you have enjoyed this video and you have understood all the concepts related to JK flip-flop. If you still have any doubts related to the JK flip-flop, please ask me in the comment section. I will try to clear your doubts as soon as possible. Thank you for watching my video. Have a nice day.